So for our practice on kind of a mixed set of examples, generally speaking, you want to start by looking for the GCF, and then based on the number of terms is what method you'll check for next. So for number one, you should have looked for a GCF first. The number here that is the greatest common factor should be 4. And then when we divide that out, we're left with x squared minus 3x plus 2. Then when we look at what's left over in the parentheses, we still have a trinomial, which means we can try that technique and it will work here. So I'm just going to record off to the side because it says to write our technique that we used GCF, and now we are going to use trinomial. So we need our x games, the top number here. So when you're building the x games, we do not use the GCF. If you take that out, we're just going to be looking at what's inside the parentheses. So the top is just 2. The bottom is just negative 3. So what two numbers multiply to positive 2 but add to negative 3? We're looking at negative 1 and negative 2. Now, important here that we do not forget about the GCF, so I am going to make sure that I keep bringing that down. And we'll rewrite the trinomial as now what we know is a grouping problem. Then I'm going to switch colors here, underline the two things that we need to group. So again, GCF is still out in front. And now the GCF of this first two terms is going to be x. The GCF of the second two terms is going to be positive or negative 2. Because I know that I want this to end up being an x minus 1, like we had here, I actually am going to take out a negative 2. So that's a little bit tricky. But we'll see why I did that here in a second. So when we divide by negative 2, we'll be left with positive x and negative 1, which is exactly what I needed, so that, again, the two leftover sets are the same. So our final answer here would be GCF of 4. Then we have a common factor of x minus 1, and the other factor is x minus 2. Now, example 2. Again, start by looking for a GCF. And I know right away these two numbers are both even, so there has to be at least a GCF of 2. In this case, if I think a little bit higher, the GCF would be 4. So we're at 4t squared minus 25. I was thinking about the next technique when I said that. And then our dots technique is where I make my little factor trees and think, okay, what times itself gives me 4t squared? Should be 2t. And what times itself gives me 25? Should be 5. So again, don't forget about that GCF. And then we'd have 2t plus 5 and 2t minus 5. Now, if you would have forgotten to take out the GCF and just done dots right out the gate, because that also would have worked, it just means that at the end you would have had to take out the GCF from both of your two factors. All right, number 3. Again, I always like to start by looking for a GCF. In this case, I know that numerically 4 is a GCF, and they both have an x and a y, but no more than one x or one y. So we're going to divide each term by 4xy. And then we'll just see what's left over to see if we can keep going. So first term is going to be left with y cubed. Second term, 32 divided by 4 is 8. And the x's and y's will both cancel. Now at this point, I would be thinking, because there's two terms left over, will dots work? The problem is if I try to make my little factor trees, y cubed, I can't make that happen because I'd either need like y times y or y squared times y squared. Same thing with 8. There's not a perfect number that if I multiply it by itself, it's going to work out to 8. I need a square root. So in this case, our answer is finished. And go ahead and try example 4. It's a word problem, but simply put, it just means, because they're asking for the dimensions, so think dimensions of a pool might be length times width, you're looking for the two factors. So go ahead and factor that one and check back in to check your work.